Hello, welcome to Anybody Can Learn. Today we are going to learn Principal Component Analysis PCA. So what is a data set? In a machine learning, a data set is a structured collection of related information. We use a data set to train, evaluate and test models. For example, we can collect the data about different students. Student A has a height 170, weight 65, age 20. Student B has height 170, weight 70, age 21. Student C has height 165, weight 60, age 20. So this represents a data set. How a data set is structured? A column represents examples or observations. It is also called as a sample. So student A is a one example, student B is another example, student C is another example. Each column represents a single instance of the data. That means it is called as data point. So column means a data point. A row represents a feature or label. Height, weight, age are known as features. Each row represents a specific attribute about those examples. Type of dataset. Dataset vary widely depending on the type of the problem the machine learning model is trying to solve. Tabular data, image or video data, text or NLP data. Tabular data. Tabular data is a structured grid containing numbers and categories. Example, predicting house prices using a square footage and location. Image video data means collection of multimedia used for computer vision tasks like facial recognition or self-driving cars. Text or NLP data, human language dataset used to train language models. For example, customer reviews or social media posts. Data points and feature. A data point is a single distinct observation or instance. So, student A is a single observation. Therefore, it is called as a data point. Student B is another single observation. So, this is called as another data point. And student C is another single observation. So, this is called as another data point. Therefore, we have three data points A, B and C. It is a single unit of information that a model uses to learn patterns or make a prediction. Data points are denoted by symbol small n. Features are the attributes, height, weight, age are the features and they are denoted by the symbol D. So we have four features: name, height, weight and age. The shape of the data matrix is D cross N. So this is our data matrix and its shape is D means row and N means column. So it is a D cross N. Therefore its shape is 4 cross 4. Convention is that vectors are column vectors. We consider a vector as a column vector and its shape is D cross N. In this X vector, X is a column vector by default and it has a D rows D rows means 1 row, 2 row, 3 row, 4 row, 5 rows, and single column. Therefore its shape is 5 cross 1, and transpose of vector means a row vector. So X transpose is row vector. Suppose in our examination, if D is given as a set of x1 to xn, so x1 to xn means number of samples or number of examples. D represent set of data set. X is called as a data matrix, and the column means a data point. So x1 is a single observation, or it is a sample 1, x2 is sample 2, x3 is sample 3, so on till xn is a sample n. So data point means a column and features are represented in a row. What is meant by dimensionality? Dimensionality refers to number of coordinates. N means n coordinate or n dimension. This is read as R30. 30 means n. So n represents the dimension or number of coordinate. Or it can be also read as a 30-dimensional real vector space or a 30-dimensional real space. Every vector in this space has exactly 30 real number entries. So X is our column vector with a 30 real number entries. 30 because n is coordinate, number of coordinates. So this 30, therefore we have the 30 entries in our column vector. What does mean by R? R means a set of real number. So it can be a positive real number such as a 5, 12, 3.145, etc., or negative number like -2 or -7.5, or 0, or fractions 3 by 4, or irrational numbers square root of 2, pi, or e. Suppose a person has only 3 features: height, weight, and age. Then one person's data is written as a single column vector. This vector belongs to R3 because it has exactly 3 real numbers. So this person's data can be represented as a column vector with a 3 real number entries. So 170 means height, 65 means weight, and age is 22. 3 because it has a 3 features. Supervised learning. If a data set contains an answer or labels, then machine learns from this provided answer, and it is called as a supervised learning. Look at this data. In this data, we had given an answer as an adult or a child. So this is called as a supervised learning. Answers are also called as a labels. If a data set doesn't contain any label or answer, then machine discover the pattern itself from the feature alone. This process is called as a unsupervised learning. In this data, we didn't mention adult or child, so machine learns from the features. Therefore this is called as a unsupervised learning. Unsupervised learning means no labels, no answers. Representation learning and compression. Representation learning, the goal is to understand something useful about the set of a data points. A representation is a way to describe data mathematically. The entire student is now represented by just 3 numbers. Student can be represented with height, weight, age, that is 170, 65, 20. Data compression. Data compression is a technique used to reduce the size of the data set. So, larger data set is reduced to the smaller data set by the help of the data compression. Data compression is used to save storage, reduce the memory, and speed up the training and inference time. So, larger data set is converted into the compressed data set. PCA, principal component analysis, is a dimensionality reduction technique. It reduces the number of features in the dataset, but at the same time it keeps the most important information intact. A complex dataset has many features. PCA, principal component analysis, reduces the number of features, but it preserves the most important information from the dataset. It changes the complex dataset by transforming a correlated feature. It creates a smaller set of uncorrelated components. So what do you mean by the principal component? A principal component is a new synthetic variable. It is created by combining several original related variables. And principal component represents an underlying pattern in the data, or it represents underlying trend in the data. It is designed to capture maximum possible variation, and it remains entirely uncorrelated with other components. Component hierarchy. In a large data set, variables are often overlap, repeat, or correlate. Principal component analysis identifies this pattern and condenses them. PC1 means first principal component is the most important component. PC1 capture absolute largest amount of variation. That means it capture maximum variation. PC2 is second principal component. It is the second largest amount of information. It capture second largest amount of information, and PC2 is exactly perpendicular to PC1. That is, PC2 is uncorrelated to PC1. Subsequent components PC3, PC4, etc. are calculated next. They capture remaining variation in descending order of importance. This bar diagram represents hierarchy of components, that is capturing variation. First principal component, this is our first principal component. It captures the absolutely large amount of the variation and hidden information in the original data. Second principal component captures the second largest amount of information, and it is strictly perpendicular to PC1. That means PC2 is uncorrelated to PC1. Subsequent components like PC3, PC4, PC5, etc. calculated to capture remaining variation in descending order of importance. PCA identifies overlapping patterns and condenses them into rank hierarchy. Each subsequent component captures less variation but operates in completely new correlated dimensions. How PCA works? The maths. The mathematics steps are: PCA uses a linear algebra to transform the data. It finds new features, eigenvectors and eigenvalues, and these new features are calculated from the covariance matrix. So from the raw data we first calculate covariance matrix, and from covariance matrix we calculate eigenvectors and eigenvalues. Eigenvector represents the direction and eigenvalue means the importance. The PCA, principal component analysis, select the top components with the highest eigenvalues, and finally it projects the data onto them to simplify the data set. So this is our linear algebra pipeline, and that is how PCA mathematically transform the data into new features. Data input means the raw data with correlated variables. Covariance matrix maps the relationship, overlaps and patterns between all the variables. Eigenvector dictate the direction. Eigenvector dictates the direction of the new axis. Eigenvalues dictate the importance, the variance capture. And projection, the data set is simplified by projecting it onto the top components with the highest eigenvalues. So this is our projected data on the top component. Application of PCA. PCA allows dimensionality reduction without losing a core information. So visualization of the 20 variable data set is impossible. So PCA reduces that data to the top 2 or 3 components so that we can easily create 2D or 3D scatter plot. Machine learning, reducing the feature removes the noise or redundancy. It makes the predictive models faster and more accurate, and make the model become less prone to overfitting. Example is that we analyze the 100 house. Original data has a 10 different size related variables. These include lot size, bedrooms, living room areas, etc. Instead of 10 variables, PCA calculates the two principal components, PC1 and PC2. PC1 means overall house size, a single number for the overall footprint. PC1 captures 80% of the data set's variance. PC2 is floor plan balance, distribution between the house and yards. PC2 capture an additional 15% of variance. So we preserve almost 95% of the total information. PC1 80 plus PC2 15, that gives 95% of total information. So we successfully remove the redundant matrix. Thank you.